Daniel Swain, I wanted to talk to you because I think a New York Times op-ed writer got it perfectly right when he described the last few months as, quote, the summer from climate hell all across Earth, when it ceased being possible to escape or deny what we have done to our planet and ourselves. When you saw the events of this summer unfolding, from severe storms, severe fires, severe floodings, severe weather in general. What were your thoughts?
Well, I think that that op-ed did summarize the same kind of sentiments that I've been feeling, and that I think that a lot of my colleagues in climate science have been feeling too. One of, in some cases, shock, but also not surprise. Scientifically, because unfortunately, this is not a fluke. This is part of a long-term trend in this direction. So if this were some random aberration, in some ways, it would be challenging this year, but it would almost be more reassuring, because then maybe perhaps it wouldn't happen again next year and the year after that. But the reality is, what we're seeing on a warming planet is more and more of like what we've been seeing this summer.
I don't mean to be a Debbie Downer, Daniel, but are we at the point of no return?
So, I think a lot of people have that exact question. Have we hit an inflection point? Is the warming accelerating? Is there a point of no return? And I do have some better news on that front, at least, which is that because the problem is the accumulation of heat trapping greenhouse gases in the atmosphere caused by human activities, this isn't some magic alien space laser that's heating up the planet. It's us, which means that we can fix the problem. The challenge is we're not necessarily doing that with the level of urgency and seriousness that we would need to be doing to solve the underlying problem of global warming and all of the changes in climate that's bringing about. But it is still a solvable problem. If we can, as rapidly as possible, bring most of our global carbon emissions close to zero, we will, to the best of our scientific understanding, stop the warming.
We'll never be able to reverse it, though, will we?
Well, reversing it is harder than slowing and then halting it. That is true. Although in the long run, over thousands of years, if we do bring our emissions back into equilibrium with what the Earth can handle, essentially, the Earth will start to cool again. That's not going to happen in our lifetime, but it is something that, just as an illustration of the fact that this is a problem that is induced by the way that civilization has developed over the past couple hundred years, it would then go away if we stop doing that.
Let me ask you a question that's been at the center of the debate. How much of this is the Earth's natural warming and cooling cycle, or how much of it is it created by human beings?
Yeah, I think that's a good point to bring up, because the Earth does experience natural periods of warming and also natural periods of cooling for a variety of reasons. Sometimes it's variations in the amount of energy that's coming out of the sun and reaching Earth. Sometimes it's because the Earth itself, over many thousands of years, has tilted on its axis slightly differently, which affects the seasons and which parts of the Earth are getting more of the sun's radiation. Sometimes it's something from the biological or the chemical world, where maybe there's a bunch of volcanic eruptions that block out the sun or belch out a bunch of heat-trapping greenhouse gases naturally. All of those things can and have happened many times in the Earth's history over thousands and even millions of years. But what we know is that the rate at which the Earth is warming now is unprecedented. And the reason we know that this is because of human activities, there's actually what we sometimes call the human fingerprint of global warming. And essentially, the amount of warming we've seen is almost exactly the amount of global warming that we would have predicted if it were almost exclusively due to those greenhouse gases. One of the big challenges with the warming that we're currently experiencing is that on a geologic Earth history kind of timescale, if you take the really long view, it's happening almost inconceivably fast. So this is not a few degrees of warming happening over 100,000 years. This is a few degrees of warming happening over the course of an individual human lifetime. So 50 years, less than a century. These are changes that people, of course, alive today and alive in the future, are already experiencing pretty acutely. And it's not just a problem for human systems, of course, but also for natural systems, for ecosystems that too are accustomed to a particular envelope of temperature and precipitation and other climate conditions like that. And so once you start pushing ecosystems to the upper end of their tolerance range, they might be able to handle it once or twice. But once we start doing it over and over and over again, and then pushing them beyond that upper range, that's where the problems start to arise.
Daniel, I would love to discuss some of the events of this summer. July was the hottest month on record, period. Why?
What's remarkable about this summer is that the record-shattering heat has occurred not only over land, but also in the oceans. And in some cases, it's resulted in pretty dramatic numbers, like the bathtub or really even hot tub level water in certain parts of the shallow coastal regions off the Gulf of Mexico, with water temperatures near southern Florida reaching essentially 100 degrees Fahrenheit at times, and any number of places on any number of continents. In fact, to my knowledge, every continent this season has broken some temperature records except for Antarctica. And that includes continents in the southern hemisphere that are currently experiencing winter.
Let's talk about record flooding we've seen in places like Vermont. How is global warming or climate change responsible for that and other flooding we've witnessed?
So in a warming climate, the atmosphere itself essentially acts as an increasingly large kitchen sponge. And of course, a kitchen sponge, you can soak up water with it. The bigger the sponge, the more water you can soak up with it. But you can also wring out more water if that kitchen sponge is saturated and it's bigger than it used to be. So as that atmospheric sponginess increases, we tend to see more rapid evaporation on the one hand, as that sponge soaks up water, but also more intense precipitation on the other hand, as that atmospheric sponge wrings out increasingly much water in single short, sharp bursts. And so in a warming climate, we expect to see, and are now beginning to see all around the world, an intensification of the hydrologic cycle, more intense downpours, and also faster developing and more intense droughts in many regions because of this increasing atmospheric sponge. So it doesn't necessarily mean it rains more all the time in all places, but essentially what it means is when it rains increasingly, it pours. You see heavier downpours, more extreme rainfall events, and therefore more extreme flash flood events, like a lot of the ones we've seen not only this summer, but in recent summers as well. And what we also see on the other end of the spectrum, because the atmosphere is also therefore thirstier, if you will, than it used to be, it wants to demand more water from the landscape. So there's potential for more rapid evaporation from soils, more rapid transpiration from plants. And so what ends up happening is this alternation between extremely wet conditions on the one hand and extremely dry conditions on the other is really one of the characteristics that we're seeing around the world today.
So, what has messed up the sponge in the first place? Why isn't it working as it should?
It really comes down to some basic thermodynamics, that the warmer the temperature of the air, the more water vapor it can potentially hold. And it doesn't mean it necessarily holds more all the time, but since it's raising the ceiling essentially on how much water vapor can be there, you then raise the ceiling on how intense precipitation can become, as well as how rapid you can suck up that water from the landscape through evaporation too.
If rising temperature creates severe rainfall, then why doesn't the aforementioned drying of the land absorb that severe rainfall? Why are we seeing so much flooding?
This is a great question. It's actually a research question that we posed recently ourselves. And the answer is a little bit complicated, but I think we can make some sense of it if you just bear with me. The challenge is that in a lot of cases, the places where the precipitation increases are greatest are not where the drying on the dry end of the spectrum are greatest. So sometimes there's a mismatch between the places that are seeing much larger increases in extreme precipitation versus the places that are seeing increases in droughts. So to some extent, it's because these are happening in somewhat different places. But in some spots, we actually are seeing both together, more extreme precipitation and more extreme evaporation and drier soils on average. So you might think that those would sort of cancel each other out. And it turns out that they do for the smaller flood events. And this resolves a little bit of a paradox that we've seen in hydrologic and atmospheric sciences, which is that we haven't really observed a large increase in the number of mild to moderate floods in many regions, despite the fact that we know extreme precipitation is increasing. It turns out this is probably the reason why. Those drier soils are allowing a certain amount of that extra intense precipitation to become absorbed and not contribute to runoff and flooding. But what we found, a little bit concerningly, is that that's only true up until a point. And so the floods that we observe the most frequently, the smallest ones that are the most common, may be sort of staying about the same as they used to be because of this balancing effect. But the very largest floods, the most extreme and damaging floods, are likely to be increasing regardless, because at a certain point, a certain extremity of precipitation, you overwhelm that negating influence of drier soils.
I was going to say, is there a point where dry soil has lost its capacity to absorb intense rainfall in a short amount of time? So it's incapable. So it creates flooding situations.
Yeah, I think that's another element here as well. And so the net result is that, unfortunately, what it looks like is probably going to happen is that the floods, the largest, rarest, and most dangerous floods, the ones that cause the most problems, as you might imagine, are precisely those that are likely to increase the most in a warming climate, even if the more ordinary, less dangerous events don't necessarily increase to the same degree.
Daniel, I'd like to read a quote from a climate adaptation expert at Tulane University living in low-lying New Orleans. His name is Jesse Keenan, and he said, "Another Katrina is going to happen. I tell my students this: within your lifetime, Tulane will no longer be a university. Your alma mater will relocate or disappear because of where it is." Now, he's telling students that this will happen in their lifetimes. What's your reaction to that?
Well, unfortunately, I think there's a good chance that he's right. And this is not something that is isolated to New Orleans, which is, of course, a very low-lying and in some cases below sea level part of the Gulf of Mexico region. But there are any number of other places around the country and around the world that are likely to see similarly transformational changes. Sea level rise is a really big deal, and sometimes it feels gradual. But I think the folks who live in places like New Orleans or Miami or Virginia Beach or any number of other places along the US eastern seaboard or Gulf Coast are starting to realize what this means, because there's an increasing number of days in a typical year where there's just flooding on sunny days. It's literally called sunny day flooding. But of course, that's not even the biggest problem. The biggest problem is what happens when you add that increase in sea level to a major storm surge from a hurricane. And although New Orleans is kind of the poster child for what the consequences of big storm surges from hurricanes can do to a highly populated area, there are many other places in the world that are actually at high risk as well. And I think that sometimes it takes a major event to shock us into understanding what that looks like. We did see that, unfortunately, with Katrina those years ago back in New Orleans. But Miami hasn't had a modern Katrina. We had Sandy, in New York, but that was, as bad as it was not a worst case scenario still. And so I think what we will see is that many coastal cities globally are going to have to either change pretty dramatically, or they won't be able to continue existing as they have in some cases for centuries.
And of course, the aforementioned drought is making situations extremely ripe for these raging wildfires that we've witnessed, not only in Canada, but most recently in Maui. Can you talk about those events and why global warming made it a perfect storm for these tragedies?
So there is actually a growing amount of evidence that climate change is increasing the level of wildfire activity and severity in many fire-prone regions and also some not so fire-prone regions historically as we get warmer. And the main reason for this is because a warming climate increasingly dries out the landscape. So the main connection between the warming we're seeing and the increase in wildfire activity in many of these regions is because the vegetation that burns during these fires has opportunities to become drier than it ever has been before. And so as we see this unfold in certain regions that see a lot of fires, it's because conditions are getting drier on average. But in other places, this is happening because the driest of the dry conditions are getting drier, even if those places aren't necessarily getting drier overall. In other words, even if you're not necessarily seeing less precipitation in some regions, we are still seeing more rapid evaporation from the landscape. And during droughts, we're seeing that vegetation is becoming even drier than it has been before. And all of that is increasing the flammability at landscape scales because the vegetation simply burns more readily at a higher temperature, producing larger and more intense fires.
Is that what happened in both Canada and Maui?
I think it's at this point, it's clear that there's a climate connection probably in both regions, but the climate connection is stronger for the Canadian fires because some of the strongest links between wildfire and climate change are in large contiguous forests. And of course, most of what's burning in Canada this summer unfortunately, are these vast boreal forests, these enormous forested regions that extend for hundreds or even thousands of miles in the subarctic around the world. So they exist both in Canada and in Siberia. These are places that historically were often pretty damp, where fires that did occur would often be sort of self-extinguishing, or they would smolder rather than burning many thousands of acres at a time. But this year, what we've seen are record-shattering hot temperatures in this subarctic region and other parts of Canada as well, along with record dry conditions in some cases. We've just seen these unrelenting ridges of high pressure just bring hot and dry for almost the entire summer across much of Canada. And that really has dramatically increased the level of flammability in the forests that are now burning. In Hawaii, that tragedy was not really a forest fire. It was essentially a grass fire that quickly engulfed the coastal town of Lahaina. And so even in Hawaii, there's evidence that the dry side or the lee side of the Hawaiian Islands are becoming warmer and drier in a warming climate. But in grassland ecosystems, it's not quite as clear the degree to which the warming that we've seen has actually made that disaster worse. So while the Canadian wildfires, I think it's fair to call them a poster child for the connection between climate change and wildfire generally, I still think the links are there in Hawaii, but they may not be the main story of what's going on there right now.
What impact does the smoke emanating from these wildfires that came well into the United States have on climate change in general? Does that exacerbate the problem?
Well, as of this conversation, what we've seen is that just in Canada this summer, the extraordinary fire season up there has emitted an amount of carbon into the atmosphere that's more than 3 times any amount in the existing record from satellites, which goes back about 25 years. So that's a really shocking number, to triple the previous record in a single year. So there are globally significant carbon emissions coming from some of the fires that we're seeing right now. We've seen this from the Western US in 2020 and also from Australia, similar amounts during the Black Summer there back in, it feels so long ago, but it's really only been a few years. There's just been so many of these events in so few years. So the smoke, of course, has other effects. So the carbon emissions from fires isn't really what you see when you have the poor air quality that blows downwind. But the smoke that we've been seeing throughout Canada and also now in the eastern US, which is downwind of a lot of these fires, that smoke is, of course, also coming from the combustion of all of this vegetation up there in the boreal forests. But that smoke is really bad for us. I think we're only now in some circles recognizing just how dangerous some of these wildfire smoke-induced air pollution episodes can be. They have enormous public health impacts. The number of emergency room visits skyrockets. You don't want to go outside. People and schools and businesses aren't able to operate as they normally do. So I think what we're realizing is that even if you aren't directly in the fire zone, even in some cases, if you're hundreds or even thousands of miles away, you can be pretty severely impacted by these fires through the essentially uncontrollable smoke plumes that can last for weeks or months on end. These fires are still burning, and some Canadian cities have been dealing with this all the way since May.
Daniel, you've warned that there are many more hotspots in the US that could be at risk of wildfires in the coming years, namely coastal communities of New Jersey, the Blue Ridge Mountains in North Carolina, and in parts of the upper Midwest. That surprises me. Why are those areas vulnerable?
Well, I certainly don't think you're the only one who's surprised. Some of that comes from just understanding the natural fire history of North America. So, climate change, of course, is increasing the risks, but a lot of those risks were already there to begin with, and we just haven't really seen them realized recently in the modern era. A lot of folks are surprised to learn that one of the deadliest and largest wildfires in US history occurred in Wisconsin. In the Great Ph.D. Fire in the late 1800s. This actually happened the same day as the Great Chicago Fire. Not coincidentally, it was very hot, dry, and windy. But it's just an illustration that even if some places, Minnesota, land of lakes, this is not a dry region in general, but it's a place that if you do get dry enough conditions, if you get a severe enough drought, extreme enough heat waves, and couple it with a strong wind event, you can get destructive and even catastrophic fires in unusual places. And this is sort of true of the other regions you mentioned as well. Many of these coastal New Jersey communities are downwind or east of the Pine Barrens. And usually New Jersey is quite a damp place in summer. You get those summer downpours. You generally don't get extremely dry conditions in summer like you would in California, for example. But every once in a while, sometimes you get a spring that's incredibly dry and the vegetation is still dormant following winter. If we got a strong enough wind event in those cases, that's another place that's a little bit surprising, I think, to many folks that could be at high risk. And so I guess the broader point there is there are some places that are obviously at risk of wildfire in a warming climate to an increasing degree. These are the places you'd expect, these California communities, Colorado, places in Canada and Australia and Southern Europe that often see fire will see more intense fire as the climate warms. But there is also going to be the opportunities for more potentially destructive fires in places that just haven't seen them or have only very rarely seen them historically. And we're seeing expansion of fire regimes even into tropical rainforests. We heard about all the Amazon fires a couple of years ago, and the Arctic, which are ongoing even this year. Now the fire regime in the Great White North it's not so white anymore, and there is sort of this unearthing of latent fire potential. I mean, in some cases, the real question about climate change and wildfire is what happens given a spark. That spark could be from lightning, it could be from a power line or an errant cigarette butt, or just someone who gets unlucky and has a car fire on the side of a freeway. All of those things have been causes of wildfires just in the past couple of months. So the point is, though, once that happens, once there is that spark, once there is an initial small fire in the vegetation, what happens next? And what climate change is doing is greatly amplifying the likelihood that those initial ignitions go on to become large, intense, and dangerous conflagrations that become difficult to control and can really adversely affect both communities and ecosystems. So it's, what we're really doing are altering the preconditions in a way that increasingly favor more severe and larger fires.
Before we depress the hell out of everyone, Daniel, what can be done to fix this problem?
I think it's important to recognize that, when it comes to individual actions in climate change, that one size does not fit all, and that individuals are going to be in different circumstances and will be able to do different things. But one example, I think, something like that the recent IRA in the US allows people to do, for example, if you own a home or you have decisions about what gets installed in buildings, maybe at work, is to really advocate for electrification of your own home, of the buildings that you work in. Increasingly, there are movements to replace gas appliances with electric ones, or to replace cars that burn gas for those that use electricity. And while this on its own doesn't solve climate change, it sets us up for a world where everything is electrified and where we can clean up the power grid, and that does ultimately help us solve global warming. And so doing what you can if you own a home, doing what you can if you don't own a home, talking about this with your friends and families, because on average, most people don't hear very much about climate change in their day-to-day lives. So changing that too, even just a casual conversation with your neighbor or someone at the coffee shop, I think is a great way to do something every day too. So the range of actions is all the way from big purchases that you might be able to make, all the way down to just having a conversation with somebody on your morning walk.
Finally, Daniel, when you look toward the future, do you do so with optimism or pessimism?
I think as a climate scientist, I would say that I have some pessimistic days and some optimistic days. And I think that's largely guided by the fact that, on the one hand, I think we've got some difficult years to come. Things are going to get worse before they get better. That is, the reality of the climate system on the path we're currently on. There will be more warming, and we're going to have to hopefully adapt to it, or if we don't, we're going to suffer even more. However, this again is a problem that is eminently solvable. It's a problem that we created ultimately, and we can fix. And the good news is that to the best of our scientific understanding, it's still fixable. And once we bring our global carbon emissions close to zero, that rate of warming is going to drop to close to zero. And so that will essentially solve that problem when we do that. And I do think it's a matter of when rather than if. But the real danger is that we wait another few decades to seriously get started and to really bend that carbon curve.
Daniel Swain, thank you so much for this really important conversation.
Thanks again for having me.